This is Algebra 1, Lesson 23B, Part 2. This is a Geogebra demo of the additive property of equality. We talked about seesaws, we talked about equations, now we've got a balance. And you can see that the left quantity, x plus 4, is equal to the right quantity, 7. We can tell that they're equal because of the way they are balanced. Now, I would like to find out what that x value is. Now, I know you already know what it is, right? It's 3. 3 plus 4 is equal to 7. But I need you to know algebraically how to show it for future reference, okay? So what we're going to do is get the x by itself. There's a 4 on that side with the x. So let's take off the 4. So we have a box here, left side adjustment. I'm going to go in and say I want you to add a negative 4 to that side. Now look what happened. Its weight is less, so it went up into the air and the right side went down. I do not have a balanced equation anymore. So I've got to do the same thing to the right side. So let's adjust the right side. Let's tell it to add a negative 4 to this side and see what happens. Now we have balanced again. Once they're balanced, we're ready to solve the equation. Aha! And we find out that when you take the 4 off the left, you're left with just x on the left side. And when you take 4 off the right, you're left with just 3. And x is equal to 3 because they balance. Here's another example. X plus 5 is equal to 6. I know you know it's got to be 1. 1 plus 5 is equal to 6. But how could you show this algebraically? Well, again, on the left side, we have x plus 5. We need to get rid of the plus 5, so x is by itself. So what could we add? Well, what if we added 5? What if I tell it to add 5? Oh, wait a minute. I just made that even heavier, didn't I? And I didn't get the x by itself because x plus 5 would be x plus 10. So that's not going to work. Let's tell it to add a negative 5. Okay. So that took some weight off. The x is going to be by itself. But now I need to balance the equation. So we go to the right side and let's add a negative 5 to the right side. Now we are balanced. Let's solve the equation. And we found that x is equal to 1. The last thing I want to address is that there are several acceptable formats of how to show your work. And your book shows you this. The one way they did, and I had never seen it done this way, is said negative 4 is equal to negative 4, okay? And we are adding that to both sides. And we find out that x is equal to 2, okay? So 2 plus 4 is equal to 6. We can find out that the solution here is equal to 2, or the root. Another way to do it, this is the way I do it, is show that I'm going to add the negative 4 to both sides. I don't put an equal sign between it. I just draw a line on either side. They actually drew a line all the way across, which would be fine, just showing that you're balancing. And then you have x is left is equal to 2. I usually, when it cancels, I'll just draw a line through it like that to help me visually see that it did cancel. You don't have to do that. Again, we find our solution is x is equal to 2. Now, some people do it this way. They take the original equation and they say, now I'm going to need to add a negative 4 on that side. And then the original said 6, so let's add a negative 4 on this side. X plus 4 plus a negative 4, these two will combine to give me 0. And 6 plus a negative 4, the signs are different, so you subtract and get 2. Keep the sign of the one with the largest absolute value. So we find out that x is equal to 2. To me, this visually, I get confused about what was there already and what the new stuff is. I like a more vertical placement instead of a horizontal placement of the equation, but it's totally up to you because all of these are acceptable. You do what makes sense for you.